Hello friends, this is my project VIMANA which entered for Hackaday Prize Re-Engineering Education. This is a VIMANA flight controller board basic version, and this board support 2 DC motor interface and 2 servo motor interface. On back side you can see there is a N76E003 microcontroller, LDO and 2 MOSFETs, while on this pad IMU is not installed. So this is the basic version, and using this basic version I have configured this basic airplane which controlled simply using the differential thrust. So by changing the collective thrust of this 2 motor, plane can gain the height or descend to the ground, and by changing the differential thrust between these 2 motors, plane can turn means your left side and right side. And so in this setup, as you can see, there are only 2 motors which produce the thrust and also control pitch and yaw of the airplane. There are no servo motor installed on elevator and rudder. This is a VIMANA basic board attached here, and this is a 3.7 volt lithium polymer battery, 20C and 300 mAh capacity. So now let's see the basic demo of this airplane using the Android application. So let me first turn on the airplane. To turn on the airplane, I just need to connect the battery with the VIMANA flight controller board. Okay, so let me turn on Wi-Fi. So as you can see, VIMANA VT101 is the access point name of the airplane, and the password is VIMANA101, and it's already connected. So let's first see the demonstration with portrait app. So this is the VIMANA portrait app. Okay, in the application I am going to Let's Fly menu.
Pilot, welcome to VIMANA team. You are flying VIMANA aircraft today. Jai Hind.
Okay, so by moving this stick upward and downward, we'll change the collective thrust, and moving it to left side and right side change the differential thrust. This application also support gesture control. Currently gesture is off. If gesture is enabled, just by changing the throttle and tilting the phone left side and right side, you can easily control the airplane using one hand. Okay, so this is the arm button. Currently the plane is not armed. Once the plane is armed, the status LED start going to flash, 2 quick flash. So let me arm the airplane.
Victor Tango, runway 1. You are cleared to take off.
Okay, so just by increasing the thrust, the collective thrust of the motor going to increase and plane will pitch up. Okay, by moving the stick left side and right side, change the differential thrust. Okay, so by moving the stick on right side, the left side motor will speed up and right side motor will speed down, and the reverse for the opposite side. So plane will turn this side and plane will turn this side. Okay.
Engine off.
So the application also support rate. So currently the rate is low, which is suitable for beginner. If we want to do some aggressive flying, we can go for high rate. So let me enable the high rate.
High rate activated.
So in high rate, the maximum throttle goes up to 90% of the motor capacity, and differential thrust is going to be double. So we will be having a quick maneuvers. So let me turn on or arm the airplane.
Victor Tango, runway 1. You are cleared to take off.
So as you can see, there is aggressive differential thrust. Okay, so let me enable the gesture control.
Gesture control activated.
So using the gesture control, just by tilting the cell phone, we can change the differential thrust. Okay, so on the Android application, we have timer, flight timer on the center. We have battery voltage on the right side and the signal strength on the left side. This button is for manual and autonomous mode. Currently this is a basic Vimana flight controller board which doesn't have a IMU, so we can't go for auto mode. This is the auxiliary channel. We can interface some LED strip instead of servo motor if we want, and we can control this LED strip or some other payload using the auxiliary button. So let me disarm the airplane.
Engine off.
So now for this Vimana basic differential thrust based simple airplane, let's see the demonstration using the portrait app. So let me open the app.
Pilot, welcome to VIMANA team. You are flying VIMANA aircraft today. Jay Hind.
Okay, so this is a similar application, but instead of one auxiliary channel, we have total 3 auxiliary channels. Low rate, high rate is supported. Then mode is also there. This is mode 1, suitable for right-handed flyer. Mode 2 is suitable for
Activated throttle on right hand.
left-handed flyer. So I am right-handed. I am using mode 1.
Activated throttle on left hand.
Okay, so to arm the airplane, we need to select the arm button.
Victor Tango. Runway 1. You are clear to take off.
Okay, so using this we can change the throttle, and using this stick we can change the U. Let me use the high rate.
High rate activated.
Okay, so we are just using the differential thrust here. So in this pad, vertical movement will change the throttle, and horizontal movement in this pad will change the differential thrust to turn the plane left side or right side. So once kid is comfortable with simple differential thrust flying and comfortable with designing airplane with a natural stability, they can go further to experiment with different design that will require the control surface also for the maneuverability. So in this setup I have just attached two servo motor. This is servo motor 2 and this is servo motor 1. This servo motor is going to control the yaw, and this servo motor is going to control the pitch, means it will change the elevator. So currently arms are not installed. This is just demonstration. So as you can see, this is a yaw control, and this is the pitch control. Okay, so servo motor can be controlled while the airplane is not armed. The motors can be only turned on when the airplane is armed, just for some safety purpose. Okay, so let me arm the airplane.
Victor Tango. Runway 1. You are clear to take off.
So as you can see, and this is the pitch. So in this setup, instead of two motor, one can interface single motor with a bigger propeller and higher capacity. The MOSFET installed on Vimana board is capable to provide a 4 ampere current maximum. So we can go for 8.5 cross 20 mm DC motor with a bigger propeller. This is 55 mm prop, With single motor we can go for 70 props, and using the 70 prop we almost get the maximum thrust up to 50 grams. So 50 gram is enough to make an airplane up to 80 gram all up weight. Okay.
Engine off.
So this is a basic version of Vimana airplane, maybe without servo motor or with servo motor. But there is no automatic flight stabilization as IMU is not installed on this particular board, and the firmware is also not supporting IMU for this board. Okay, so there are certain advantages of not having IMU for kids. So basically, as you can see, if I'm going to tilt the plane, there is no automatic correction right now, so the kids need to design the airframe which is naturally stable. Okay, they need to play around with the dihedral angle, polyhedral angle, they need to play around with the center of gravity. So they will learn several concepts of STEM using this basic version. Basically I have no plan to introduce IMU, but just for the sake of, let me turn off the motor first.
Engine off.
So just for the sake of experiment, in this particular board I have installed the IMU. This is LSM 6 DS3 6-axis accelerometer plus gyroscope combination. This is interfaced with ESP8266 over SPI. All the flight stabilization done by ESP8266, and PWMs are controlled by this N76E003 microcontroller. Okay, so the thing is, this board is having a flight stabilization, and I have just make this for the experimentation, and maybe it is useful for the kids when there is a heavy wind gust outside and still kids want to fly the airplane. And obviously because there is a IMU, there are certain more STEM related concept of flight stabilization student will get learn using that. There is one biggest advantage I want to add for this project. This VIMANA flight controller board is not programmable at the user's end. Yeah, it's advantage basically. Though I have made everything open source, considering firmware of the chips used in this project as well as Gerber files of the hardware, everything is open source including the designs of these airframes. Okay. But still the board is not programmable from user's end. As you can see, there is no dedicated USB port or a programming header made available. It's just to reduce the cost. Okay, so maybe you have the question why it is advantage. Basically it's not programmable and I'm saying it's advantage. So yes, it's basically advantage because the main goal of this project is to take the kids away from the flat screen and get them into the ground. So what basically happens, kids are not going to program anything, they just going to use this board in their own creation, and they just come out from their home and go into the big garden to test their own creation or fly their own creation. And believe me, though the entire system is a smartphone controlled, but the basic aim is just to reduce the cost. I don't require any dedicated transmitter design for this project. And one more advantage is we don't want to snatch away the cell phone from the hands of kids. Kids have the cell phone, but believe me, when they are flying their creation, they are not looking at the cell phone. Basically they are looking at the blue sky and where their beautiful creation is flying. Okay, so that's all about this project so far. In next video I'm going to come up with a flying demo of a different airframe, different versions of the plane with IMU, without IMU, with servo motor, without servo motor, normal airplane in a tractor configuration, pusher configuration, with differential thrust, with a single motor, okay, paraglider, some Star Wars based airframe design. So there are lots of options available. We can also make a boat, we can make a hovercraft, and it's not only and you doesn't require this foam every time. You can use just a pizza box to make something fly. Okay, you can use the paper, you can use the cardboard, anything. Basically, if the center of gravity is proper and there are certain dihedral and certain principle of physics you have included in your design, the punchline is anything can fly. Thank you.